Hello everyone, and welcome to our Week 3 Out and About session where we learn more about the science, technology, engineering and math that's happening around us in Elkhart County. This week we've been learning about the Japanese paper folding art of origami and making our frogs jump using potential and kinetic energy. Today we visit Welch Packaging and chat with Gary Sieber to learn more about the corrugated box process and see how they're made. Who doesn't love a package arriving at the door? But have you ever given much thought about the box itself? Corrugated boxes are everywhere. Did you know that 90 to 95% of all manufactured goods are packaged in boxes just like these to help protect what's inside? And what's cooler is many of these boxes are made at Welch Packaging right here in Elkhart.
Guys, hi. Today we are here with Mr. Gary Sieber from Welch Packaging, aka a giant Corrugami factory. All right, can you tell us the difference between a cardboard box and a corrugated box?
Sure. What we make at Welch Packaging is not cardboard. Most people would say a cardboard box, but this is cardboard. Cardboard is one ply, it's, nothing on it. You can see it's kind of floppy. You might find this in a drugstore if you're buying cough syrup or something like that. It gets folded up into what's called a folding carton. So that's cardboard, or chipboard as it's sometimes called. This is corrugated. So corrugated packaging, you see that, but it has a liner on the top, it has a liner on the bottom. It's just like an Oreo cookie.
You guys make corrugated boxes.
Can
you tell us a little bit about your corrugation process?
And this is what we call a medium. We actually have and these little arches few box plants. We have our own corrugator, which you can see the fluting. If you look at the side, the corrugation process starts with in one direction or the other. So this is corrugated packaging, taller than any of you are, I'm sure, out there. They might be 10, 12 feet tall. In a big brown box. Those go on, it's generally going to be corrugated. That peels that paper off, and the first thing that's created is the squiggly is made by corrugation first, it's called single phase, and that's so it creates those flutes, and then we match that, and you can see all the squigglies. We've just basically taken the liner off for you, so you can see what the squigglies look like. Medium, again, called a medium, and these are called flutes that you see running through it. And so they produce two things. One, cushioning. If you want to package something to provide cushion, those flutes compress down. But when you stand them straight up, they produce rigidity. So like this, if you stack the corrugation in the vertical direction, these are like little pillars that add strength. So you can stack these boxes sometimes 30, 40, 50 high, and the boxes on the bottom won't crush because they have these pillars providing strength.
Now let's take a quick moment to link corrugation and the concepts you've learned this week. As we've gone over this week, we have been talking about potential energy, which is stored energy, and kinetic energy, which is energy in motion. We've also learned that every paper fold in our origami acts like a spring, where when we push down, we are storing energy, and when we release, it's converted to kinetic energy and the frog jumps. Corrugation is used for shock absorption to protect what's inside. Here's a cross-section of a box where you can see the ripples, which are called flutes. Kinetic energy from an object hitting a box, or the box hitting the ground, gets absorbed by the ripples and redistributed. You'll notice that the flutes look like arches. Arches are very strong shapes and are good at redistributing force. They're often used in bridges. Corrugation is also used to create strength. The weight or force from a box or another object gets absorbed and redistributed by the flutes, which act like pillars. Pillars are very strong and are used to provide strength. Corrugation is the reason why we can stack boxes without them collapsing.
Plus, since you guys make corrugated boxes, can you tell us a little bit about your corrugation process?
We actually have a corrugator. We're one of the few box plants. We have our own corrugator, which you walk through and you'll see pictures of. But the corrugation process starts with rolls of paper. Huge rolls that are taller than any of you are, I'm sure, out there. They might be 10, 12 feet tall. Those go on to a machine that wheels that paper off, and the first thing that's created is the squiggly part. So the corrugation, the medium, right? So it creates those flutes, and then we match that and glue it to a liner. So you've got the liner, the corrugation, the medium, and then another liner on the outside. And the great thing is you can keep building that. So you can have a liner, a medium, a liner, another medium, another liner. We can make double wall, triple wall, however strong we need the box to be, we can create that. And these papers, these liner papers, actually come in a variety of different weights. So if you need a stronger, heavier, stouter box, we just get heavier paper. And customers tell us what they need, and our designers work with them to say, this is the kind of box that you should have for something that weighs that much or for this purpose that you have. This is what we call an FOL. Why is it called an FOL? Because it's a full overlap. So these, the flap comes all the way across and the other one goes all the way across. So somebody might want a full overlap if they're concerned about dust getting in, if they want a little bit more of a secure seal. We have trays down here, die cut trays, infold trays. This is just a scored sheet, so you can see the scoring that's on here. That's just a dent, so it folds easier. We use scores to make sure that we can fold. So that's part of the origami too, because this stuff would be hard to fold if you didn't score it, right? So that's just a scored sheet. We have, this is an RSC, regular slotted container. So when you fold those up, the two flaps meet right in the middle. That's how you can tell an RSC. This is the most common box that we do for anyone. And again, if you made this about 10 times bigger, it might be an Amazon box, that you'd get. So it's the same thing on the bottom. The two flaps meet in the middle, and usually you put a piece of tape across it. So this is a standard brown box that people would be familiar with. This OPF is what I was showing you earlier. And if you're shipping a box, the two ends fold up, the two sides fold up, and bada boom, bada bing, you got a box. And it's all just one piece, and you don't have to do anything other than lay a piece of tape across the top. So, people have different needs, and this is all sort of the brown stuff that we do. And then we have all the graphic things that we do as well. And graphics can be separated into two broad strokes. One would be an example of what we call a direct print. So in this case, Notre Dame pizza box. I don't know if you can feel it, but there's kind of a rough feel to it because we're actually printing the ink directly onto the corrugate, right onto the surface. So we have a print plate that rolls across that and puts that ink right on the box, okay? So that's one way of putting graphics on a box. The other way is what we call a labeled box. It's probably not a great example because let's use, I don't know, all I have is beer and guns, right? But here's KitchenAid blender box. We sell a lot of these. Now this you can see is photographic. There's like 6 colors in here. There's blends and different things. But we actually print, and I'll show you when we get out in this first plant, this is actually a very thin lithographic sheet that is printed separately, and then we glue the sheet, the label, right onto the outside of the box. So it's different in the sense that we're not putting the ink directly onto the box like we did with this one. So you can kind of see the difference in the way that they look. These are going to be the flashy ones, the glossy ones you might find in Kohl's when you go in and buy a blender. You're going to see these kinds of things. And it's all about marketing. It's about cost, it's about marketing, it's about what you want to say with your product. So this is where we get into the statement boxes, right, of things that are designed to sell. Generally speaking, you have about 7 seconds. We know that consumers spend about 7 seconds looking at a box before they make a decision either to look more or move on. So if your box doesn't make an impression in that first 7 seconds, you've lost a sale. That's our CAD table, and we can walk in there. But you were asking how these things get cut. That's what cuts it. So it has like an X-Acto blade on it. It is laser driven, and James is our operator up here. So he is controlling everything with the computer. It pulls up a CAD. He's right now looking at the next CAD that he's going to do, but it's working off of a CAD like you saw in our design shop, and it is just going through the process now of cutting exactly what's on that CAD. The computer drives the head, and it's sort of laser guided, but it has an actual blade, a scoring blade and a cutting blade that will cut whatever we tell it to do. So at the end of however long this process takes, whatever that is, we'll take that off the table and we'll turn it into the packaging it was meant to be. Normally we use the CAD table only to cut samples for a customer. So when we get to the point, we start with those first questions: what kind of box do you want? And they decide, okay, I want this, I want that. Then we create a structural sample and we will take it to them and say, is this what you have in mind? And they'll say, yes, no, it has to be tweaked, it needs to be bigger, it needs to be smaller, I like this, I don't like that. And then we'll bring another sample until they sign off on it. And once we know that structural sample is exactly what they want, then we can go into production and put it on our bigger machines. Single face. You can see the liner on this side, you see the ridges on that side, so this doesn't have a label on it, right? And this is what we create in the front end of the machine. The label gets put on this side. It's over here, I think already now. There's a label, the thickness of it, right? So that's going to become the outside liner on the box. And then glue it together. The box is good. Alright, so this is a die cut box. So it's gone through the machine over on the other side. Put the label on it. It's a long label. Okay? And all of this is going to fold up into a box. You can see how there's a window cut out, slots have been cut out, the scoring has been put in. So there's a lot going on here. And all of that, it goes from being just a plain rectangle to this, through this machine. As it comes through, there's this die in there that you can see through that window. And that's how this box comes through. Stand across to create all of the cuts. So remember, this is just one solid rectangle. Now it's been cut so that it has all it starts to take shape here. This is what the die cut looks like. It doesn't look anything like the finished box, does it? You can see the glue tab over here. So this is going to fold up in this direction, but it's also going to fold up in the other direction because these tabs down here have to come together and be glued. This is a special kind of box. It's called an auto bottom. It saves the customer a lot of time in terms of labor because they don't have to fold the box and tape it on either side. The box just pops open. I'll show you that when we get down there. But I wanted you to see what this looks like before it's actually folded and glued. So if we go down. After it's glued, this is what it looks like, okay? And you notice the bottom kind of has a funny look to it. Workers, when they fill these over at a firm at Avalon Industries, they can just pick one up off of the stack and do this. So they don't have to tape the bottom. It's all set to go. It's what we call an auto bottom, an auto lock, crash lock. And so you have a box that's all set and ready to go. And if you think about it, if you had to take a box, open it, fold it, tape the bottom, turn it over, pack it, tape the top. It would take a long time. So we can save, something 50-70% labor and time to put these boxes and pack them out, because you just pick it up, snap it, and ready to go. Okay?
All right, can you tell us a little bit more about how you started off in the box business?
Yeah, it was a strange journey for me. I actually have a science background. I started at Notre Dame as a physics major. And you say, what? Physics, right? Yeah. But when Scott Welch first asked me if I wanted to work for him, I said, doing what? He said, selling boxes. I said, absolutely not. I can't think of anything more boring than selling a box. But actually, as he laughed about that, but we talked for several months, and as I walked through the plant, as you guys did today, you saw that there's a lot more that goes into these than might meet the eye. There's a lot of science that goes into it. There's steam, there's adhesives, there's paper, there's technology, there's these arches, which we call flutes, that provide either cushioning or stability depending on how they're oriented. You've worked with our designers who really have to have all of that in mind. So the science background actually helped quite a bit, and the more I got involved in it, the more I realized, this is a pretty interesting thing. It's not just a box. There's much more to it than that. Physics helps in the sense that I can look at a problem and I can understand from a customer's point of view what they're trying to achieve, and then look at structural things that we can do to say, here's how we can either solve a problem, here's how we can save you some money. It might be in reduction of materials, it might be in reduction of labor costs, because we can design a box that snaps together faster so that they can do more packing in a shorter amount of time. So the box might cost more, but the overall cost of them is less. And when you start putting a lot of numbers together and start thinking about design concepts and things like that, the science background comes in handy. That doesn't mean that you have to have a science background to work in boxes, and in fact I'd say most people don't. But for me, it became a natural progression from where I was at, and I've really enjoyed it. There's just much more to it than you would ever think when you say, it's only a box.
A special shout out to Welch Packaging for being our sponsor this week.